Hey there! Have you ever had to write the same number over and over again? Like, what if you needed to multiply 2 by itself 5 times? You'd write 2 times 2 times 2 times 2 times 2. That's a lot of 2's. Well, in math, we have a super cool shortcut for that. It's called an exponent, or a power. Exponents are just a shorter, neater way to write repeated multiplication. Think of them as a mathematical shorthand. By the end of this video, you'll be able to explain what exponents are, identify their parts, and even use them to make prime factorization much easier. Let's dive in. So how does this shortcut work? Let's go back to our example. Instead of writing 2 times 2 times 2 times 2 times 2, we can write it like this: a big 2 and a small 5 floating up high. This is an exponential expression. It has two main parts. The big number on the bottom is called the base. It's the number that gets multiplied. The small number floating up high is called the exponent, or the power. It tells you how many times to multiply the base by itself. So, 2 to the power of 5 means you take the base, 2, and multiply it by itself 5 times. It's a compact way to say, multiply 2 by itself 5 times. Let's try another one. What about 3 to the power of 4? Here, the base is 3, and the exponent is 4. This means we multiply 3 by itself 4 times. So 3 to the power of 4 is 3 times 3 times 3 times 3, which equals 81. See how much neater that is? Now, let's talk about how exponents can make prime factorization much easier. Remember prime factorization? It's when you break a number down into its prime building blocks. Let's take the number 24. We can use a factor tree to find its prime factors. 24 can be split into 2 and 12. 2 is prime, so we circle it. 12 can be split into 2 and 6. 2 is prime, so we circle it. And 6 can be split into 2 and 3. Both are prime, so we circle them. So, the prime factorization of 24 is 2 times 2 times 2 times 3. Notice anything? We have the number 2 multiplied by itself 3 times. This is the perfect place to use an exponent. Instead of writing 2 times 2 times 2, we can write 2 to the power of 3. So the prime factorization of 24 becomes 2 cubed times 3. It's much more compact and easier to read. Exponents help us write these long lists of prime factors in a neat, organized way. It's like tidying up your math work. Alright, it's time for some quick practice. Let's see if you can identify the base and exponent. First one, 7 to the power of 3. Take a moment to think, what's the base and what's the exponent? If you said the base is 7 and the exponent is 3, you got it. The base is the big number and the exponent is the small number up high. Great job! Let's try another one. Next up, 5 to the power of 2. What are the base and exponent here? That's right. The base is 5 and the exponent is 2. You're getting the hang of this. One last quick one. This time, let's write it out. How would you write 11 times 11 times 11 times 11 using an exponent? The base is 11, and it's multiplied 4 times, so the exponent is 4. The answer is 11 to the power of 4. Fantastic work! Let's quickly recap what we've learned today. We started by looking for a shortcut to write repeated multiplication. We found that shortcut in exponents. Exponents are a neat and tidy way to show that a number is multiplied by itself multiple times. We learned that an exponential expression has two parts: the base, which is the number being multiplied, and the exponent, which tells us how many times to multiply it. And we saw how exponents can make prime factorization much cleaner, turning a long list of factors into a compact expression. You've now met exponents and seen how they can simplify your math. You're well on your way to becoming a math whiz. For homework, I want you to find the prime factorization of 72 and write it using exponents. Give it a try. You've got this. Thanks for watching.